Hey guys, welcome back to General Chemistry. Today we're going to talk about Avogadro's law. So Avogadro's law is going to be our last of our basic gas laws. So Avogadro's law tells us that the volume of the gas is directly proportional to the moles of gas. This is probably the most intuitive of the gas laws. So if you think about blowing up a balloon, right? So if I squirt a little helium into that balloon, what's going to happen? It gets bigger. Squirt a little bit more in, it gets bigger. Squirt a little bit more in, it gets bigger, right? You've got a balloon that's full. I let go. What's going to happen? All of the air is going to come rushing out, so the amount goes down. And then the volume of that balloon is also going to shrink. The sides are also going to come in as well. So volume and amount are directly proportional. So if we think about the volume and the amount as being directly proportional, what are we holding constant? Well, what we're holding constant in this case is going to be the pressure and the temperature. So by increasing the number of particles, that would result in more collisions. So to keep the pressure constant, we must pull the sides of that container away from those particles so that the number of collisions stays the same. Vice versa, if we let some of it out, that's going to result in less collisions, so we're going to have to squeeze the sides of that container closer to our particles so that we maintain the same number of collisions. With Avogadro's law being much like Charles, where it's directly proportional, we're going to see that the formula is very similar. So the formula for Avogadro's is going to be N1 over V1 equals N2 over V2. And then the solving of these would be very similar to Charles' law, in that you would cross multiply and solve. I don't have an example of solving these because it's the exact same procedure as Charles' law. So that's really it for Avogadro's law. The next step we'll take is pulling all these properties together and looking at the ideal gas law. I hope you found this helpful.